Hey guys, how's it going? I think you can see me. I want to do a quick video today. It's another work project. One of the project managers wanted to see inside this inductor. So this is an inductor used in a power electronics application. And, excuse me, still getting over my cold here. You want to see what the construction is of it. To determine if we want to go to a different vendor or to understand if there's something we can do to cost reduce it. There's a new project coming up, so it's one of the vital components. So what I did is I said I would take it home and chop it on the horizontal bandsaw, slice and dice it, and see if we could see what was inside of it. I'm sure we will be able to cut this, and I think it's going to give a perfectly smooth finish so that we can see what's inside. Now, this orange here is definitely some kind of potting of some kind, and you can see the wire leads coming out. So I imagine what we have is an iron ferrite core in here of some shape, possibly two of them, and then these would be copper wires that are wrapped around the ferrite. And then the whole thing's encapsulated here in the epoxy of some sort. It'll be pretty easy to cut through everything except the ferrite, the iron core. It's probably just going to be tough and dense. So I'm going to set it here on the horizontal bandsaw and just let it go as it wants to, as far as feeding itself down. And I'll probably shoot it with a bunch of WD-40 or something just to keep it kind of lubed and get all this crap out of here. I think it's going to be pretty nasty. So what I did is, I can't really hold this in the horizontal bandsaw very easily. You guys can see, you know, it's got this sheet metal case around it, and this sheet metal case is real flimsy and stuff. So I wanted something beefier to hold on to it. So what I did is, whenever I go to IKEA, I grab these cutting boards. These cutting boards are made out of probably a medium density polyethylene. They're not high density and they're not low density. They're somewhere in the between, and they're $1. And I'll grab a stack whenever we're there. I'll grab 10 or a dozen or whatever, and I throw them under the table here in the parts section or the material section. And I use them for all kinds of random little fixtures, holding things if I need some plastic that I don't really care about. So that's what I did. I took one of these. I just laid this thing on here and just squared it up to the sides and put 4 tapped holes in it just with a hand drill, just real fast. And I got, I think, 832s in here. So I got 4 screws holding it down. On there it's pretty solid. Then I can go ahead and put this in the horizontal bandsaw to get a lot of good clamping pressure, and then I may end up adding some other clamping here. Now I'm pretty sure the sheet metal case is going to want to rip out and bend apart, at least at the initial cut, because if you look at it like this, the horizontal bandsaw is going to be coming down like this, so it's going to catch this edge and probably want to rip that sheet metal right apart, which is no big deal as long as it doesn't catch and rip this thing or tear it out of this cutting board. Will be fine. We'll see how it goes. So I'll meet you over at the horizontal. Alright, over here at the Kalamazoo horizontal bandsaw, go ahead and get this up. I got the jaws open quite a bit here. We should be fine. Take this guy. Now we may have to move this one support. Oh, it's going to be fine. Now, he had a couple of marks here. I'm just going to assume he wants it in the center. Let me grab a scale. None of this is really critical. Again, we're just kind of opening this up to see what's in it. Okay, it's about 4.5 inches overall. Let me go 2 1/4-ish. Like that. Yeah, it's kind of flexible out here. Let me grab a clamp of some kind. Throw it on the end there. Just a C-clamp. Is that gonna fit? Nope, of course not. Let me grab a deeper one. Got all the clamps stored there in the other room, so I had to go grab one. Oh yeah. Wants to kick off. There we go. Stiffening that up quite a bit. I'm moving around. This is still going to rip off, I'm pretty sure. Alright. Get some power here, see how it goes. Alright, we got the hydraulics opened all the way up, so it's just the weight of the bandsaw now pushing down on this, and you can see it's stalled out quite a bit. This is what I assume we're hitting some of that ferrite iron core there. Grab some lube. See if we can't make a dent in this thing. freaking nightmare. Wow, that stuff was way harder than I thought. Or this blade is more trash than I thought. Probably a combination. Oh. That looks pretty disgusting. Yep, I see copper. Makes sense. What we were thinking. Oh, this is gonna be disgusting. Of course, it's covered in WD as well. Oh, Mama Luca. There you go. Here's the inside. See? Big old copper. Big ferrites in the middle. Another one here, another one here. Alright. Let me get some of this crap cleaned up. I'll bring you back. Alright guys, here you go. Here they are. Just cleaned them up. So you can see you got, let's see if I can get this. The wires coming in, and then they're obviously coming in here into these copper coils that are surrounding the ferrite. And this ferrite is actually probably a donut. So a donut all the way through, and then it's got another core here, another ferrite iron core here. So anyway, they look identical. They were a complete pain in the butt to cut there. And I think I really trashed the blade I had in there, but it was kind of an old blade, so I'm not too worried about it, not too concerned. So anyway, there you go. Something a little different today. Most of us mechanical guys never see a lot of these electrical components, especially these ones that are magnetic components like transformers and inductors. So it's kind of cool to see the construction, see how they go together. Good thing for us to see. Alright, we'll catch you next time.